I'm thrilled to recognize Kaunas University of Technology's groundbreaking project, Digital Twin for Buildings Operational Carbon Evaluation, which has been awarded a prestigious Founder's Honor. This innovative project, developed by the Kaunas University of Technology, KTU, Faculty of Civil Engineering and Architectural Center for Smart Cities and Infrastructure, focuses on monitoring and managing the CO2 emissions, energy consumption, and indoor climate of the KTU campus buildings. By leveraging state-of-the-art digitization technologies, the project aims to significantly reduce the carbon footprint and enhance the sustainability of the university's infrastructure. The project exemplifies innovation and creativity by integrating advanced technologies such as reality capture, Internet of Things, IoT, building information modeling, BIM, data science, and the use of AI to predict energy consumption and carbon footprint. The team utilized Bentley Open Buildings Designer to create semantically rich BIM models, iTwin Capture for reality capture, and the iTwin platform for high-level customization and data visualization. OpenCity's Planner served as the project's main platform, integrating digital outputs from various software tools and APIs. By just monitoring and making visible energy, water consumption, wastewater, occupancy temperature, relative humidity, air volume, lighting, noise, CO2 levels, and other significant indicators, KTU is changing behaviors that are resulting in more responsible use and investment in clean energy sources. In March 2025, the operational CO2 footprint of the KTU campus buildings consisted of 80% thermal energy for heating and hot water, and the installation of solar power plants and EV charging stations contributed to an 11% reduction in the carbon footprint. Congratulations to the Kaunas University of Technology for winning a Founder's Honor. Your dedication to innovation, sustainability, and excellence sets a new standard for the future of infrastructure. I am pleased to recognize Cornell University's Environmental Systems Lab for a Founder's Honor for their work on the Energy Atlas, a digital twin for decarbonizing Ithaca's building stock. This groundbreaking project is a city-scale building stock energy model developed in close collaboration with the city of Ithaca. It supports building retrofit planning, carbon reduction, and sustainability policy implementation. The Energy Atlas digital twin integrates open access urban data sets, spatial analytics, and national statistics to construct a bottom-up, physics-based urban building energy model, UBEM, that evaluates and predicts energy consumption across all 5,200 plus buildings in the city. The innovation and creativity behind this project are truly commendable. By leveraging artificial intelligence and machine learning, the team has created a high-fidelity digital twin that not only improves simulation accuracy, but also provides critical insights into building energy performance, operational carbon footprints, and retrofit opportunities. This tool empowers city officials, community organizations, and property managers to make data-driven decisions that will significantly impact Ithaca's journey towards full carbon neutrality by 2030. The use of Bentley Descartes, Cesium, iTwin Capture, and OpenCity's map enabled the team to overcome significant bottlenecks in 3D reconstruction, data interoperability, and model deployment. The automation of key components in the building reconstruction pipeline saved over 500 work hours, while the integration of Cesium for Unity led to an estimated $500 per month in software API cost savings. The metrics speak for themselves. The project has the potential to reduce operational carbon emissions by up to 95%, or approximately 104,000 metric tons of carbon dioxide equivalent annually. Additionally, the use of digital automation saved an estimated 14,000 work hours compared to a fully manual process. These achievements not only highlight the project's efficiency, but also the significant contribution to environmental sustainability. In conclusion, I would like to extend my heartfelt congratulations to the entire team for their dedication, innovation, and hard work. This project sets a precedence for urban sustainability transitions and serves as an inspiration for other municipalities around the world.
I'm thrilled to recognize CityMe's project on micromobility modeling in Abu Dhabi's strategic transport model as the Founders Honors for Sustainability. Abu Dhabi is rethinking urban mobility, and CityMe consultancy is leading the way, integrating walking, biking, and scooter trips into the city's transport planning. CityMe's micromobility project uses Bentley Open Paths to enhance Abu Dhabi's strategic transport model. By accurately capturing short trips, the project helps planners design infrastructure that's efficient, people-friendly, and environmentally sustainable. Traditional transport models mainly focus on cars, leaving short trips like walking or scootering underrepresented. CityMe addressed this with a local area model, a LAM, breaking the city into smaller zones to capture how people actually move. They integrated walking, biking, and scooter routes into the network and improved route choice algorithms to reflect real travel behavior. The model predicts how people will shift from cars to sustainable modes, helping plan cycle paths, pedestrian routes, and policies that encourage micromobility. Using OpenPaths and Cube, planners can visualize traffic flows in 3D, evaluate different scenarios, and make data-driven decisions faster. They even integrated additional data, such as building occupancy from energy and water usage to refine travel patterns. The result is a tool that not only optimizes transport infrastructure, but also enhances social and environmental outcomes. Fewer car trips, healthier streets, and stronger, more connected communities. Congratulations to CityMe Consultancy. This project has set a new benchmark for sustainable, data-driven urban planning. By integrating micromobility into Abu Dhabi's strategic model, CityMe and its project are helping the city become more resilient, more connected, and ready for the future.
Over the course of my career, the construction company that I have most looked up to is DPR Construction. DPR has uniquely championed going digital, having institutionalized virtual design and construction (VDC) across their own project portfolio and always advocating for innovative advancements which benefit the state of the art for all. That's why I'm particularly appreciative of their nomination of their Hartford, Connecticut Children's Hospital project for its 4D planning with Synchro. DPR is known for surmounting the most challenging projects, but this $300 million hospital addition and expansion is at the extreme, along with adding new capacity for a 50-bed neonatal intensive care unit and especially a rare fetal care and surgery operating room. The infrastructure complexity includes a bridge to a new parking facility. But it was the schedule and related budget commitments that caused even DPR to seek a creative and unconventional breakthrough beyond their already advanced standard procedures. To save literally months and millions, the permanent rather than temporary heating, was to be turned on for interior finishing work before even the final construction documents would be available. DPR describes the redefined workflow which Synchro's 4D capabilities made possible as plan how you want to build it, then model what you planned, and finally, go build what you modeled. Using this innovative approach, DPR completed the essential coordination of the mechanical floor a year ahead of schedule, delivering a level of development 400 detailed model 6 months before even beginning work on the steel. The validated construction sequence would then be continuously refined throughout by way of a rolling 5-week fabrication and installation schedule, which created predictability in the labor market. Synchro enabled coordination of the 200 on-site workers who understood the visual language better than words. Having precisely predicted what would be installed each week, DPR says, guess what? We hit that weekly production on time, every time. You won't be surprised that DPR are experts at quantification and learning about advantages from going digital. See here their reckoning that on this project, which was just completed, among the benefits to improve children's health care in Hartford, coordination efforts, which typically achieve around 5,000 square foot per week on healthcare building projects, were accelerated with Synchro to accomplish 13,000 square feet per week, so that the plan was built before construction documents were even issued. 92% of planned percentage completion was achieved, which DPR applauds as remarkable for such a complex project. DPR estimates that on-site labor productivity was increased by 20% thanks to the 4D modeling and its visualization, and in particular, as to the original motivation to altogether avoid temporary heating, 95% of mechanical, electric, and plumbing MEP's trade work was completed 6 months ahead of schedule. And as DPR puts it, digital twin technology was also instrumental in identifying opportunities for cost savings, such as for underground electrical vaults, which allowed for wire pulling before the switchgear was delivered, saving $500,000 in labor. And here, see DPR's summation of the advantages of Synchro's time machine, which I have less evocatively described as the digital chronology which a digital twin affords: precision, predictability, and the ongoing perfection of project plans. Thank you, DPR, for sharing this advancement, and congratulations on Founders Honors. At Bentley Systems, we're appreciative of every Going Digital Award nomination, with our users and accounts sharing their advancements for the benefit of all. But understandably, our category jurors are more likely to focus on globally significant projects that tend to be of large scale. For Founders Honors, therefore, I like to salute projects that are far-flung and representative of our growing population of users in small and medium-sized businesses, SMB. In the case of Synchro users, this can make the case that 4D construction modeling is appropriate and valuable to enable digital twin advantages not only for projects with the largest budgets and complexity, but also the smallest and everything in between. So I would like to call your attention to this nominated project by 100% Romanian firm Leviathan Group, with an all-in cost of 7 million euros to add 2 services buildings to the campus of a prestigious military boarding school which remained in session during construction. General contractor Leviathan undertook to supersede traditional scheduling tools and fragmented spreadsheets with Synchro. Leviathan integrated digital workflows that brought together typical Revit designs and procurement through Autodesk Construction Cloud, but it was Synchro which enabled a comprehensive model incorporating with the physical aspects of the building, as Leviathan puts it, the temporal dimension. 4D scheduling enriched the 3D elements with the 470 engineered activities across all phases of construction for real-time visual simulation of project evolution, dynamic clash detection to coordinate 10 subcontractors, site logistics including sequencing, crane placement strategies, and equipment circulation paths, and scenario analysis for potential disruptions such as weather events and to adaptively reallocate resources when supply delays occurred. By Leviathan's reckoning, quantitative benefits from maintaining full critical path integrity with Synchro and constituent transparency through Synchro control included 25% reduction in workforce congestion delays, 42% fewer site visits, 35% reduction in construction punch list items, 28% savings in storage space, enabling procurement efficiencies, and 18% reduction in carbon emissions. Finally, the project's social impact not only improved the cadets' life in preparation for their important futures, but transcendently also benefited the future in Romania by, to quote, illustrating the profound potential of digital solutions to deliver sustainable, impactful infrastructure projects. Along with congratulating Leviathan for Founders Honors, I particularly thank them for sharing this encouragement to construction projects of any type and scale anywhere that they found advancing from 3D to 4D construction digital twins by virtue of Synchro to be very easy.
Hello, everyone. It is with great pleasure that we recognize Shanghai Investigation, Design, and Research Institute as a recipient of this year's Founders Honor for their leadership and innovation in offshore wind infrastructure on the Three Gorges project. This landmark project delivered 1,000 megawatts of capacity over complex terrain with harsh marine conditions via 74 offshore turbines and a 330 kilovolts AC booster station. The team leveraged Bentley software to engineer massive foundation piles and a 10,000-ton offshore booster platform. Using MicroStation and SACs, they implemented an intelligent design system that enabled them to increase design efficiency by 50%, reduce quantities by 10%, and save over 20 million yuan in construction costs. During pre-construction, the team used MicroStation, Open Building Designer, ProjectWise, and Synchro to develop a 4D simulation of the build. This contributed to a reduction in the build time of approximately 2 months, resulting in overall project commissioning within 8 months with no reported safety incidents. Now in operation, this network of offshore wind infrastructure leverages Bentley's iTwin technology to create a real-time digital twin that integrates over 26,000 sensors, reducing safety assessment costs by 30% and operation and maintenance costs by 15% annually. The project stands as a model of technical excellence and innovation, showcasing how multidisciplinary collaboration and the use of digital twins can unlock efficiencies in project delivery and serve as a foundation for safer and more reliable infrastructure. Finally, and again, congratulations to Shanghai Investigation, Design, and Research Institute for their innovative use of digital tools, exemplifying digital innovation in the full life cycle of offshore wind power. Their leadership and achievements have advanced sustainability and collaboration, thus earning them this Founders Honor.
Hello, I'm Graham Grant, CEO of Sequent, the Bentley subsurface company. I am so pleased to recognise as a Founders Honour Ormat Technologies. The island of Dominica in the Caribbean has some of the highest electricity prices in the world, with 70% of their power coming from diesel generators. Ormat drilled geothermal wells over 1,500 metres down to power a 10 megawatt electricity plant that will replace 50% of the diesel consumption. Ultimately, by 2030, the island will be 100% renewable power. To achieve this incredible outcome, the Ormat team has used 9 different Bentley products to design and execute this project, with results that included saving 660 engineering hours, reducing design piping costs by $100,000, and reducing the need for further wells with numerical modelling, saving $10 million. These results are very significant given the total project budget of $65 million. Here is a quote from Simon Weberson, Vice President of Exploration and Resource Management, on how Bentley's product range is used by Ormat to help provide more certainty, and the impact of geothermal can be unlocking cost-effective energy. Ormat was selected because of the substantial environmental impact they have had on this important island nation. Congratulations to Simon and the team at Ormat Technologies for their Founders Honour.
The geospatial and reality modeling category celebrates projects that demonstrate digital innovation and visualization through reality modeling, 3D geospatial modeling, mobile mapping, instrumentation, and sensor data management. We are pleased to recognize ANSYS, RF Channel Modeler, for NASA Lunar Mission Planning with a Founders Honors in this category. With RF Channel Modeler, telecommunication network systems engineers employ a model-based design approach to represent their systems within a physics-accurate digital environment to optimize base station asset locations. The site planning alternative is to go on site with test and measurement equipment. RF Channel Modeler enables NASA to do this virtually, which is essential because modeling physically on the moon is not feasible. With RF Channel Modeler, NASA performs network digital twin models for ground subscribers on the moon at 1 million to 3 million times faster than traditional digital twin modeling processes while running thousands of iterations. Going Digital saves 396 labor hours, requiring only 4 hours per project. RF Channel Modeler leverages the 3D Tiles OGC community standard created by Cesium to consume large data sets such as terrain, 3D models, and geospatial content for electromagnetic simulation, testing, and evaluation. ANSYS SDK leverages Cesium Ion self-hosted to optimize user data to 3D tiles, uses Cesium Global 3D content for geospatial context, and utilizes Cesium.js for visualization, saving years of development effort and unnecessary service engagements. Congratulations to ANSYS for this out-of-the-world use case for geospatial and reality modeling, equally relevant to telecom network and modeling on planet Earth.
The UK's uniquely ambitious High-Speed 2 HS2 project, along with the advancements being achieved by infrastructure owner Network Rail, is paving the way for the full potential of rail system digital twins. Now, this vision is being physically realized through the ongoing Old Oak Common Great Western Railway Station Rail Systems project delivered by the South Rail Systems Alliance, SRSA, comprising AECOM as the lead design organization, Colas Rail as the principal contractor, and Network Rail as the infrastructure owner. Delivering the rail systems infrastructure is the subject of AECOM's nomination for a Going Digital Award in its capacity as the SRSA's lead design organization. This project is a landmark in digital integration and collaboration. HS2 Great Western is expected to handle up to 250,000 passengers per day, making it one of the UK's most complex rail system interfaces interchanging HS2 with the Great Western Railway network, with Heathrow Express, and with the Elizabeth Line services. To provision and populate this multi-operator digital environment, SRSA, through the combined expertise of AECOM, Colas Rail, and Network Rail, has leveraged iTwin cloud services to geospatially integrate independent models across coordinate systems. This enables live tracking of design model changes across track, civil, mechanical, and plant disciplines, including throughout 1.5 miles of operational railway. The Alliance is fully utilizing the UK's established digital ecosystem, OpenRail, ProjectWise, MicroStation, and Synchro, to optimize delivery and sustainability. In the track formation phase alone, the project is requiring over 200,000 tons of cut, fill, and ballast, an effort made more efficient through digital coordination. But a commendable incremental innovation has been the adoption of the Bentley Raceway and Cable Management application, led by AECOM and supported by Colas Rail and Network Rail. This tool uniquely combines schematic and 3D modeling to design and coordinate power, signaling, telecom, and SCADA cable routes. It enables pre-construction class detection in congested corridors, reducing material usage and waste by an estimated 15 to 20%, while improving on-site safety and installation efficiency. Continued support from Bentley is enabling further development of this capability. For SRA's collective effort in broadening the scope and benefits of rail digital twins, particularly through the integration of Bentley Raceway and Cable Management, this project stands as a model for future infrastructure delivery. Congratulations to AECOM, to Colas Rail, and to Network Rail for this outstanding achievement, and for Founders Honors. In Australia, the Pacific Highway Upgrade Program has led the way there in effective digital advancements. But the $2.2 billion 14-kilometer Coffs Harbour bypass presented a new challenge. Along with highly variable geology and environmentally sensitive areas, including protected rainforests and cultural heritage zones, the steep terrain required not only 20 bridges, but also, a first for Pacific Highway, no fewer than 3 tunnels, totaling more than 1.5 kilometers. For digital engineering lead Arcadis, coordinating over 15 design partners, as they said, traditional workflows were not fit for this scale and complexity. Arcadis' comprehensive Bentley ecosystem, as they describe, and as you'll see here, took full advantage of Bentley Infrastructure Cloud, from ProjectWise through iTwin and Synchro, including to enable real-time model reviews and change tracking across all disciplines. This iTwin environment allowed Transport for New South Wales and construction partners to, as Arcadis put it, engage with the live digital twin, driving faster approvals, reduced rework, and clearer communications across all stakeholders. Arcadis further combined open roads, open bridge, and open tunnels to create a robust integrated model representing roads, structures, and tunnel geometry in one environment. Arcadis documented resulting savings of 366,000 work hours through model-based collaboration and digital workflows, plus design review cycles shortened by 60% and the elimination of 22,000 truck movements. But I would like to give credit to a particular innovation which compounded these benefits, and that is the incorporation of full subsurface analysis through Leapfrog and Plaxis, not only for the tunnels, but also for overall ground modeling to manage the geotechnical risks, tolerances, and mitigation of landslip, settlement, and structural integrity related to the soft soils, groundwater, and complex rock interfaces. The advanced ground modeling enabled early intervention in high-risk geotechnical zones, saving costly field adjustments during tunnel construction. By Arcadis' informed reckoning, this digital transformation on the project demonstrated how innovation, sustainability, and efficiency can be scaled, setting a new benchmark for digital engineering in Australia's transport sector, and may I suggest for consideration throughout the world at large. Thanks for sharing the scope of this ambition and the benefits of your innovations, Arcadis, and congratulations for Founders Honors.
I'm pleased to recognize as Founders Honors Auricon for their project Digitizing Urban Ground. Transforming subsurface engineering through 3D geology modeling is a transformative subsurface engineering project that began with Auckland City Rail Link, New Zealand's largest infrastructure effort, and has evolved into a citywide digital twin of underground conditions. It integrates over 8,000 site investigations into a dynamic 3D model across Auckland, forming the basis for all infrastructure planning utilizing Bentley Leapfrog Works, Central, and Open Ground. There were several standout innovations that Auricon accomplished in this project. They accomplished 30 to 50% improvement through real-time collaboration, 20% reduction of early-stage design time with automation of manual workflows, and alignment optimization, reducing response times from days to hours, saving thousands of working hours, all while improving responsiveness on compressed delivery programs. All of this led to 15% cost savings on average through reducing the need for hundreds of site visits, cutting drilling duplication, haulage, and material waste through the design phases, all while driving significant reductions in carbon output. Their approach also improved engagement with the Maori iwi via immersive 3D visualization of manga, aquifers, and heritage areas, contributing to more inclusive and respectful design decisions. Auricon's innovative approach enables citywide governance, delivering consistent workflows across jurisdictions, enabling competitive advantage and better end outcomes. This approach is now being expanded to other cities like Melbourne and Sydney, promoting consistent workflows and advancing infrastructure digitalization, sustainability, and cultural sensitivity, while importantly demonstrating new revenue opportunities for the firm through data reuse and modeling. Congratulations, Auricon, on your Founders Award.
We are pleased to honor Geoambiente from Brazil with a Founders Honor for their project remediating contaminated soils and groundwater. That groundwater was discharging to a nearby surface water body. The site had complicated interbedded hydrogeology that involved the saturated and unsaturated zones. Underpinned by large language models as well as digitally connected workflows, their solution resulted in considerable savings in time and capital. With so many sustainability challenges facing society, this project shows the potential of AI and digital workflows. The tangible benefits of the project included a 70% reduction in reagent use, which means $1.4 million in savings, an 85% reduction in contaminated mass, and 2,100 technical hours were saved. They also delivered 45 days ahead of schedule and achieved faster technical approval from environmental authorities. Data is always at a premium in contaminated site investigations. Geoambiente's innovative use of large language models to convert historical data into fully digital assets shows where the industry needs to go. That, alongside their digital workflows, transformed a set of raw and complicated data sets into a continuous, integrated, accessible decision-making environment with direct impacts on the project's efficiency, sustainability, and safety. Approaches accelerating environmental improvement processes are sorely needed everywhere, and when they also result in such significant economic and environmental benefits, they shine a light on how the industry should behave. We congratulate GeoAmbiente and Senor Fernandez on their Founders Award for an innovative project that highlights how AI and digital can transform achieving sustainability goals.
I'm really pleased to recognize the Lumut Balai Unit 3 project in Indonesia from PT Pertamina Geothermal Energy as a Founder's Honor for Sustainability. As global energy demand rises, we need bold solutions that deliver clean, reliable power without harming the planet. This geothermal project shows how geothermal energy can speed up the energy transition and boost climate resilience. The project will generate 55 megawatts of renewable power, enough for 60,000 homes, while cutting 300,000 tons of CO2 every year. Using Leapfrog, Oasis Montage, and Volsung from Sequent, the Bentley subsurface company, the team built advanced 3D subsurface models to guide safe, efficient development. South Sumatra's growing economy means electricity demand is rising fast, from under 1 gigawatt today to nearly 1.5 gigawatts by 2030. Lumut Balai Unit 3 will provide 55 megawatts of baseload renewable power by 2029, backed by a $33 million investment. What makes this project stand out? Its digital-first approach. By using Leapfrog, Oasis Montage, and Volsung, the team turned paper-based studies into dynamic 3D models. Experts from different fields could collaborate in real time, cutting the feasibility study from a year to just 6 months. Digital modeling also dramatically reduced drilling risk, from almost 50% to 15%, and cut drilling costs by 17%, saving $1.5 million per well. Faster, safer, and cheaper. That's how innovation accelerates the energy transition while keeping the project commercially viable. And the benefits go beyond energy. Lumut Balai Unit 3 will replace 2,600 barrels of oil per day, expand electricity access to remote villages, and improve regional connectivity with a new 7-kilometer road. This is data-driven geothermal development scaled for real impact. Congratulations to PT Pertamina Geothermal Energy. Lumut Balai Unit 3 shows how digital innovation can unlock geothermal potential, cut emissions, and power communities with clean, renewable energy. This is the kind of infrastructure that builds confidence in a sustainable future.
Hello, I am Graham Grant, the CEO of Sequent, the Bentley subsurface company. I am so pleased to recognise PT Hutamakaya as a Founder's Honour. The Trans-Papua Road project, stretching over 3,300 kilometres, is one of national strategic significance for Indonesia. The $200 million 50-kilometre Mamberamo Ilalim section is one of the most challenging parts of this project. It ultimately reduces travel time for these communities by 75%. This reduces dependence on costly air transport, it lowers logistics costs, and improves access to education, healthcare, and markets. This brings life-changing accessibility to one of Indonesia's most isolated and mountainous regions. To overcome the challenges of such difficult terrain, PT Hutamakaya applied advanced geotechnical engineering and digital construction technologies. High-resolution topographic data was captured using LiDAR and processed using iTwin capture. Sequent software tools such as Leapfrog, GeoStudio, and Plaxis were utilized for in-depth subsurface modeling and slope stability analysis. This quote from Amy Rachmadani, VP of Digital Construction, summarized the impact on how these innovations improved collaboration, mitigated risks, and ensured a safer, more sustainable delivery. Overall, they have achieved cost savings of over $1 million and reduced CO2 emissions by 50,000 kilograms. PT Hutamakaya was selected because of the incredible project, the first construction of permanent roads entirely from scratch in Papua's most isolated and challenging mountainous region, changing the lives of these communities. Congratulations to the team at PT Hutamakaya for their Founder's Honour.
It is gratifying to me each year to come across and then highlight a Going Digital Award nomination in which a relatively small company discovers and advocates an innovation in infrastructure engineering which can have widespread and substantial digital twin advantages. AquaWolf is an engineering firm founded in 2019 in the western U.S., which particularly focuses on improving energy transmission and distribution grid assets. A large utility commissioned AquaWolf to consider whether the utility's established approach for field capture and analysis of distribution poles could be improved by using the most sophisticated and rigorous structural analysis software, our Powerline Systems PLS, in which AquaWolf specializes. To test this proposition, AquaWolf resurveyed and reanalyzed distribution pole structures which had already been conventionally assessed with the legacy tool and processes, originally in that case subject to limitations of potentially inaccurate implicit assumptions. The results from full PLS models with greatest precision to evaluate real-world conditions of span interactions, loading conditions, and actual terrain alignment revealed significantly lower structure usage values, showing that some poles previously flagged for replacement, by the way at an average cost of $20,000 to $100,000 each, were in fact within tolerance. This opportunity for optimization and savings, minimizing overdesign and premature replacements while sustaining resilience, can be very significant considering the scope and uncertain condition of distribution network structures. This prospect motivated AquaWolf's principal breakthrough. The demonstrated superior PLS analysis requires more input precision and is more software intensive. But AquaWolf undertook to develop a new automated survey to modeling process which would require fewer overall resources than the legacy approach. So that, as AquaWolf put it, utilities would not need to choose between capability and cost. Rather than reducing modeling quality to control budget, they re-engineered the front end of the workflow. Rather than relying on point clouds from traditional LiDAR scanning, AquaWolf took advantage of specialized handheld Luke cameras and related software to more directly and accurately derive the needed 3D PLS inputs from Luke's overlapping photogrammic imagery and intrinsic geospatial orientation. As AquaWolf put it, so automating the path from field capture to model creation unlocked a new standard for utility workflows combining data automation, digital capture, and engineering-grade analysis in a scalable, sustainable way. A very worthwhile incremental benefit is the acquisition of high-fidelity survey-grade data as a byproduct of the capture process, facilitating the digital twin potential. AquaWolf reports that Luke is further investigating integration with PLS, including by way of Bentley's cesium platform for geospatial immersion for accessibility by utilities and their digital ecosystem to field reality as a living asset for resilient, cost-efficient networks. I thank AquaWolf for resourcefully proving out and for so effectively propounding this very promising workflow advancement. And congratulations for Founders Honors. I regard that one of the aspirations of Going Digital Awards, and Founders Honors especially, is to bring attention to innovative digital twin applications nominated by resourceful developers of a solution in one geography which could be beneficial much more widely. The PowerChina Electric Power Survey and Design Institute of Henan Province, the most populous in China with nearly 100 million people, has experienced firsthand the consequences of extreme meteorological conditions of increasing frequency and intensity, including extreme rainfall which, in July 2021, caused serious flooding and waterlogging disasters in many substations there. Fortunately for its residents and resilience, the Institute has a digital engineering center which has now proactively and entrepreneurially pioneered a digital twin solution, enabling simulations, monitoring, and decisions to protect the performance of this critical infrastructure, starting with the substations at 500 kilovolt capacity and above. The solution leverages Bentley's comprehensive digital twin portfolio of reality modeling of a substation's physical context, including any applicable flood hardening, and of course the surrounding terrain as derived by iTwin Capture and Descartes from drones and laser scanning, 3D design modeling of the substation's flood-vulnerable digital components in Open Utilities Substation for China, environmental modeling by OpenFlow's sewers, hydrological computation under flood scenarios of the impact on surface water levels, depth, flow velocities, and scour, and of course all of this integrated with IoT monitoring of rainfall forecasts and real-time rain sensor data. But what makes this digital twin application stand out for me, and perhaps what makes it now feasible, is the integration of all of this and also some incremental third-party applications, perhaps for the first time anywhere, through Bentley's cesium geospatial modeling environment and its supported WebGIS framework Python interface development. This supports, on the one hand, intuitive, immersive, as it were, visual simulation scenario assessments of flood resilience and potential mitigation decisions for each critical substation in turn, and on the other hand, a provincial flood situation deduction platform for the operational monitoring upon system-generated early warnings of actual rainfall forecast impact across the high-voltage grid. The system simulation results so far have been validated and adopted successively in more than 10 projects by the State Grid Electric Power Meteorological Joint Laboratory and the State Grid Henan Electric Power Ultra-High Voltage Branch, and are being presented among science-level peers internationally. Next targeted for this approach are the 3,300 remaining substations in Henan, which handle lesser voltages. I thank PowerChina's Henan Digital Engineering Center for sharing this practical and effective breakthrough for digital twin technology in substation flood control. And my congratulations for Founders Honors. May I suggest to everyone else how compellingly valuable it would be for all of our power grids to be upgraded to the level of flood resilience which this demonstrably enables.
Let's celebrate Forte Entablada and 17th Street Canal Pump Station Digital Twin Project as Founders Honors for Sustainability. Protecting communities from flooding is one of the most urgent challenges today. The 17th Street Canal Pump Station Digital Twin project shows how digital twins are transforming how cities like New Orleans defend themselves against climate risks. Fortin Tablada created a digital twin of the 7th Street Canal Pump Station, one of New Orleans' most critical flood defense assets. Using Bentley's iTwin native apps, together with flagship tools such as MicroStation and ProjectWise, they delivered a living digital model that strengthens resilience, preserves institutional knowledge, and enables faster, smarter emergency response. The 17th Street Canal Pump Station is a cornerstone of New Orleans flood protection, moving storm water out of the city during extreme weather. With climate change increasing the frequency and intensity of storms, the station's reliability has never been more vital. Partnering with Bentley, Fortin Tablada built a data-rich digital twin that brings together historical drawings, 3D scans, point clouds, and real-time telemetry. The result is a centralized, geospatially accurate platform accessible to engineers, asset managers, and emergency planners. The shift from static records to a live, federated model has transformed operations. Engineers can now inspect, measure, and resolve conflicts virtually, saving hundreds of hours in site visits. Over the station's lifetime, the digital twin is protected to save thousands of work hours while cutting costs and reducing environmental impact. The digital twin also sets a new standard for resilience. IoT sensors and precise geospatial alignment allow teams to track subtle elevation changes, critical in a city below sea level. It's more than an engineering record. It's a foundation for simulations, storm readiness, and collaborative decision-making. By going digital, Fortin Tablada created a sustainable framework that preserves knowledge, reduces carbon from travel, and strengthens public safety. It's a proof point for how infrastructure digital twins serve both people and the planet. Congratulations again to Fortin Tablada on their founder's honor. The 17th Street Canal Pump Station digital twin is a breakthrough in climate resilience and community protection. By combining engineering excellence with Bentley's digital innovation, they have delivered a model for smarter, safer, and more sustainable infrastructure for generations to come.
I'm excited to recognize as Founders Honors DC Water. From blueprint to reality, DC Water's digital twin implementation. DC Water serves over 700,000 residents and 26 million annual visitors in Washington, D.C., with an extensive service area of 1,300 miles of mains, with an average age of 80 years old. In fiscal year 2024, non-revenue water is estimated to have cost $57 million, indicating significant savings potential from improvements. DC Water aims to enhance its response to leaks and breaks to control costs and maintain service quality, as well as cutting carbon footprint by 50,000 metric tons of CO2, which is equivalent to removing 10,000 cars from the road, through reduced energy consumption and improved workflows, contributing to their sustainability goals. To address this, DC Water launched a strategic digital transformation under its Blueprint 2.0 plan, selecting Bentley's WaterSite and OpenFlow's Water Gems to create a real-time, cloud-managed digital twin of its water distribution system. This digital twin integrates data from multiple enterprise platforms to improve reliability, proactive resource management, and sustainability. A key innovation is the deployment of 120 sensors across 1,300 miles of pipeline, enabling Bentley's Anomaly Leak Finder to detect and triangulate leaks in near real time, supporting efficient maintenance. The system calculates water balancing using production and billing data and compares minimum night flow with hourly consumption to estimate real versus apparent loss. By going digital, DC Water has transformed its disparate data, originally gathered to support specific units, into an integrated digital twin, producing new actionable insights, facilitating proactive resource management, and enhancing service reliability and efficiency through sustainable improvements. DC Water's approach sets a new standard for urban water infrastructure, delivering improved service quality and resilience for the community. Congratulations, DC Water, on your Founders Award.